In this video, we will use series sum and LINEST function in polynomial regression. We'll generate a data set using this range of x from point 0.8, negative point 0.8 to point 0.8, and the equation y equals 1 over 1 minus x is equal to RA formula, 1 over 1 minus the x values. And we will use polynomial equation for the trend line. From the chart, we generate the polynomial equation. Our trend line will be polynomial equation. It's polynomial, but we'll make it better than 2. So we increase the polynomial degree to 3. Now that's better. Next, we calculate this coefficients using LINEST and matrix. So our polynomial coefficients will be B0, which is 8.829, which is the coefficient of x to the power 0. B1 is 0.506, the coefficient for x to the power 1. Our B2 is 2.79, the coefficient of x squared. And B3 is 3.47, the coefficient of x cubed. So our polynomial equation is in the form of B0 plus B1x plus B2x squared plus B3x cubed. Factoring out the coefficients, you will have the matrix 1 comma x squared comma x cubed, which is this matrix, times b0 semicolon b1 semicolon b2 semicolon b3, which is this matrix. It's vertical because of the semicolon. This is horizontal because of the comma. So we begin with the one column, which is RA formula of the x values raised to the power 0. Any number raised to the power 0 is 1. And followed by the x column, which is RA formula of the x values raised to the power 1. Any number raised to the power 1 is the number itself. RA formula of the x values raised to the power 2. That's the x squared column. And then RA formula of the x values raised to the power 3. And that's the x cubed column. Now we can enter the LINEST or use the LINEST function. We have data y and data x, which starts from the x column to the x cubed column. So our B0 is 0.829, which is the coefficient of x to the power 0. Our B1 is 0.5064, rounded up as 0.506. That's the coefficient of x to the power 1. Our B2 is 2.785, rounded up as 2.79. That's the coefficient for x squared. And our B3 is 3.4686, rounded up as 3.47, which is the coefficient of x cubed. We can now calculate the estimate y, which is M multi of the 1 comma x matrix and the coefficients. Because here's B0, B1, and B2, and B3 from here, from this matrix. And we can insert this to our chart. That's our estimated y. You add a series and choose the range, and it will be this range. Hit OK. Now we notice the data set of estimated y follows along the trend line because the estimated y is the equation of the trend line. Next, we use the series sum, which is RA formula. Series sum of the x values and our starting power or raised to the power 0, so it's 0. That's the re- initial power, and incremented by 1, so from x to the power 0 to x to the power 1 to the power cube. So, and the coefficients used are b0, b1, and b2. You will notice this column is the same as this column. We can prove that. We can show that in the chart. So edit chart, add a series, and we'll add this estimated y. So our estimated y and our series sum are the same. This shows that series sum in the polynomial regression is the same as the estimated y.